Hello, this is Mr. Collier, and today we're doing some properties of the vector product. Okay, so the first one's a very important one. It's A cross B equals negative B cross A. So recall that's different than the dot product. Okay, this one's different. Recall, the definition of what A cross B is. When you do A cross B, you get a vector that's perpendicular, right, to both vectors. Now if you do B cross A, you get a vector going the other way. Okay, so it's just in the opposite direction. So that's why it's negative B cross A. You can prove it if you want to by writing out the components, A1, A2, A3, and doing a cross product with B1, B2, B3, and then doing the same thing the other way around. You'll see that they're going to be opposite signs. Okay. And now if you get a constant times a value with the cross product equals constant times the cross product. That could be useful because if you had to do a cross product and you can factor out a number, it'll make the cross product calculation a lot easier. Okay, so that could be useful to factor out the scalar before you do the cross product. Okay, now A cross A is going to be the zero vector. Okay, you can see that if you do A1, A2, A3 cross A1, A2, A3, you'll get like A2, A3 minus A3, A2, and obviously that's going to be 0, and you do that each time, you get 0, 0, 0. Okay, this one here, we're going to cross it out because that's actually quite useless, but I'm going to add one, A cross B equals the zero vector if, let's write it if you get A cross B equals a zero vector, then they are actually going to be parallel. Okay, that's if they're not the same thing. Okay, so those are going to be parallel, and we do have an associative property for cross products, so this does equal A cross B plus A cross C. Alright, so we're going to use these vector products now to do a little proof. So these commonly come up. Prove that if P plus Q plus R equals a zero vector, then P cross Q equals Q cross R, and that equals R cross P. So let's start off, let's do each of these and show that they're equal. So you start with P cross Q. Okay, P cross Q, you can rearrange this one. You can rearrange this one here for Q, for instance. Okay, so you can rearrange this to Q equals negative P minus R. Okay, so I'm going to rewrite this as cross with negative P minus R, and then I'll do the cross product. We're going to get negative P cross P minus P cross R. And remember, P cross P gives you the zero vector, so this is negative P cross R, which equals negative or positive. Remember, if I rearrange them, it changes the sign. So that equals R cross P by that one of the properties we just talked about, right? Now, if you do Q cross R, so we just showed that P cross Q equals R cross P. Now let's go over this one. So if I do Q cross R, that equals Q cross negative P minus Q. We can rearrange this to solve for R, and we get this. That equals negative Q cross P minus Q cross Q. Again, that equals a zero vector again, so we got negative Q cross P, which equals P cross Q. So you can see now that all three of them are equal to each other.